Hello everyone, my name is Prathamesh Jaju and today I want to share my journey of astrophotography. With the Big Bang, this universe sprung into existence and the energy condensed into hydrogen atoms. That was more than 13 billion years ago. It's fascinating to see how these hydrogen atoms go through numerous transformations, star explosions, and nuclear fusion reactions until they reach a point where they can take photos of themselves. Yes, we all descendants of those primordial hydrogen atoms. We're all made of stardust, which makes these stars, planets, nebulae, and galaxies our siblings. I'm an amateur astronomer and astrophotographer from Pune in India. I've been fascinated by the wonders of our universe ever since I was 8 years old. I used to watch movies and TV shows related to space and science all the time. To learn more about astronomy and astrophotography, I joined an astronomy club in Pune. I started taking photos of the night sky and the celestial objects when I was 13 years of age, which was almost 4 years ago. I have been trying my best to improve my processing skills and learn new techniques to make the photos look better. So, is the telescope really a time machine? Astronomical objects are so far away from us that even light, the fastest object known to us, takes over thousands of years to reach us on Earth. If we start with the Moon, the distance from Earth to Moon is approximately 3 lakh kilometers, that is 1 light second. The distance from Sun to Earth is 8.2 light minutes. Now let's take another famous astronomical object, which is the pole star. Pole star guides us in the direction of the north. Polaris is approximately 430 light years away from Earth. This means that we are looking at the pole star how it looked like at the time of Sir Isaac Newton in the 16th century. Hence, the telescope is a time machine and astrophotography is capturing images of astronomical objects in the past. Now, I would like to share my journey of capturing images of astronomical objects through the years 2017 to 2021. The images which you are seeing right now are the very first images that I captured with a DSLR camera and a tripod in 2017 and 18. What you see in these images are the Himalayan mountain ranges in the foreground, and in the background there is the Milky Way galaxy's Sagittarius arm. We see a lot of stars, and some features which are darker than the rest of the sky are the dust lanes of the Milky Way. Back then, in 2019, when I traveled to one of the darkest sites in the world, Spiti Valley, I didn't know much about astrophotography, but just the basics. I carried only a DSLR camera and a kit lens with me. I placed the camera steady on a rock, I elevated it with the help of a bow, and I captured multiple long exposures of the Milky Way galaxy and then further processed them to get these results. The Moon. The Moon itself is a very special object. It is very bright, easy to locate, and the fact that it shows phases is something very exciting even to kids. Even 4 years ago, Moon was always exciting for me to look and photograph at. You can see my journey of capturing the Moon from 2018 to 21. Last quarter mineral moon. This is my most detailed shot of the last quarter moon. Any image that we look at on our mobiles and laptops get blurred or pixelated when we zoom into them. My idea behind this image was that when I zoom into the image, it shouldn't get blurred or pixelated. That's why I captured 38 videos at a higher magnification. Because of the higher magnification, I could see only a small area on the moon's surface and not the complete face. Now, I did not have images but videos. So each video had to be made into an image by stacking the individual frames together. Now I had to repeat the same process for 38 times. That's when I got 38 individual images. Now I have to match these images like a jigsaw puzzle, and in the end what I had is this image in front of you. So the 50,000 images were not photographs but the sum of all the frames that I have used for generating this very image. And the overall data of the videos and images is around 186 gigabytes, which is indeed the image size. We usually see the moon in the shades of grey, but the colors which we are seeing in this image represents the mineral-rich surface of the moon. Different minerals on the moon's surface emit different colors. Our eyes cannot see them, but different types of cameras can detect them. In order to see those colors vibrantly, we need to enhance them. The blue tones reveal areas rich in ilmenite, which contains iron, titanium, and oxygen, but mainly titanium, while the orange and purple colors show regions poor in iron and titanium. Let's talk a little about a few concepts in astrophotography: noise and signal. Noise and signal are possibly the two most important concepts to understand when it comes to astrophotography. Essentially, noise is something unwanted and we just want to get rid of it. And the signal is the pretty stuff that we want to capture. So we want lots of signal and as little noise as possible. One way to remove noise and enhance the signal is by stacking images. In astrophotography, this is done by aligning and adding the signal of the images and enhancing the image details and brightness. So what we have to do is that we capture multiple images of the same camera settings and then merge them into one. What stacking does is that it averages out the unwanted junk, that is the noise, and enhances the signal, and it produces a much cleaner and sharper image. Now let's talk a little about the future of astronomy and astrophotography, the James Webb Space Telescope. James Webb Space Telescope will act like a powerful time machine. It will capture light that has been traveling across space for as long as 13.5 billion years, when the first stars and galaxies were formed out of the darkness. Webb will be able to see infrared light, that is light just outside the visible spectrum and just outside of what we can see with our naked eyes. Its unprecedented sensitivity to infrared light will help astronomers to compare the faintest earliest galaxies to today's grand spirals and ellipticals, helping us understand how galaxies assemble over billions of years. It will tell us more about the atmospheres of planets orbiting other stars and perhaps even find the building blocks of life elsewhere in the universe. Webb's 18-segment primary mirror is over 6 times bigger in area than the Hubble Space Telescope and will be 100 times more powerful, which is 6.5 meters in diameter. Hopefully, the James Webb Space Telescope will be launched this December. Now, this is all the good stuff that we talked about. There are many different setbacks and challenges like inadequate gear, bad weather, or lack of confidence. But that is also the reason why we shouldn't stop. In 2019, I traveled over 1,000 kilometers to observe a rare astronomical phenomenon, which was the annular solar eclipse with my astronomy club. Annular solar eclipses are really rare. They happen as early as 150 years or as long as 200 years from one location. So this was really exciting for me, traveling all the way to Coimbatore in southern India. We set up all the telescope and all ready with the equipment, and this is what I saw. Do you want to see the beauty of annular solar eclipse? This is the first lesson I learned in astronomy and astrophotography, that we are not always lucky. I'm not superstitious, but events like these made me think that there is something of a cloud curse. Whenever there is some rare or any astronomical event, there are clouds covering the entire sky and ruining it. Luckily, 6 months later, there was another solar eclipse from my own city, Pune. It wasn't an annular solar eclipse, but a partial one, and this is the result what I got. We can do astrophotography with any camera and telescope available to us. Nowadays, even smartphones are capable of capturing beautiful images of the night sky. It is not the worth of equipment that makes up for a good astrophoto. It is the person who is behind the camera and telescope throughout the night. If astrophotography is a vehicle, then its fuel is patience. We might not get the best of the results right away, but that's all the reason why we need to keep practicing with the hobby so that we get the best of the results. If you look at the image that I captured of the Milky Way galaxy, it isn't really that beautiful, but there I was sitting in a dark, cool location with just a DSLR camera, and I was able to capture the light coming from our own galaxy. It just blew my mind, and I really can't express the happiness that I get every time that I capture an image of the cosmos. Spending time doing an engaging activity that is unrelated to work or other routines will help us feel pleased and satisfied with our lives. It will allow us to devote time to activities that are solely for our personal advantage and not for the benefit of others. Everything we wish to accomplish demands some effort, but how crucial is that effort in reaching our objectives? What we do today, the effort we put in, impacts our success in the future. For extraordinary results, we need to put in extraordinary efforts. I hope everyone stays curious and had a good time listening to my talk. Thank you.